Number 18, for the cost and price functions below, find A, the number Q of units that produces the maximum profit, B, the price P in dollars per unit that produces the maximum profit, and C, the maximum profit P in dollars. They give us the cost equation is 50 plus 10Q E to the negative 0.01 Q. They give us that the price, in terms of Q also, you don't have to write that, but that's what it means, is 50 E to the negative 0.01 Q. So the first thing we have to do is remember that for profit, that's capital P, it's the revenue. Let's see, this is based on Q this time. So P of Q, the revenue of the quantity minus the cost of the quantity. Now, the one thing we don't have here is the revenue based on quantity, which remember is price times quantity. So it's going to be our price, 50 E to the negative 0.01 Q times Q. So our profit is going to be this revenue, and I'm going to move the Q right behind the 50. It just makes it a little bit easier to keep up with, minus all parts of the cost. Look, so all parts of the cost. So minus 50 and minus 10 QE to the negative 0.01 Q. Now, because I moved this Q here, hopefully you'll recognize that this term and this term are actually like terms because they both have a Q and an E to the negative 0.01 Q. So 50 of those take away 10 would be 40 Q E to the negative 0.01 Q minus 50. So to find the maximum, we need to take the derivative of the profit function. So the profit prime Q. Now, I got to be careful here. 40Q is a function, and E to the negative 0.01 is a function. So we have to use the product rule. So remember the product rule? The product rule says if you have two functions in your variable, that is Q in this case, then you have to take the first times the derivative of the second plus the second times the derivative of the first, and it really doesn't matter as long as you have the original function times the derivative of the other, and then vice versa. So I'm going to go first function, 40Q. Derivative of E is E to the U. So it's the original E function, and then the derivative of that would be negative 0.01. So that's going to be times negative 0.01. So that's the first derivative of the second, plus the second, E to the negative 0.01 Q, times the derivative of the first, which is 40. All right, I'm going to clean this up a little bit. If you multiply 0.01 negative times 40, we get negative 0.4 Q E to the negative 0.01 Q plus 40 E to the negative 0.01 Q. And all I did here is I moved this 40 to the front. Look, these have a common factor of E to the negative 0.01 Q, and that's going to leave me negative 0.4 Q plus 40. Now, if you remember about E functions, let's just take a quick look. When you have an E function, it has an asymptote on its left tail here. Notice it's getting close to 0, but it's never 0. And if this is a negative exponent, in fact, let's do the negative 0.01. It's kind of hard to see it, but let me zoom out. Same sort of thing, except it's flipped over going the other way, but it still never crosses 0. So that's really helpful to us because this can never be 0. So this is never equal to 0. So all we have to do is we have to take our negative, so all we have to do is take our negative 0.4q plus 40, set that equal to 0. So it's negative 0.4q equals negative 40. So q is negative 40 divided by negative 0.4. So negative 40 divided by 0.4, also negative, gives me 100. So my quantity is 100. Nice, good number there. Okay. Now, let's go fill out a few things. First, they ask us for the profit function. So we reduced our profit function, and this is what we came up with. So let's enter that first. 40q e to the negative 0.01q subtract 50. The number of units produces the maximum profit. Well, we're assuming it's at q equals 100. Now, of course, that would only be true if the first derivative is positive here and negative here, right? Because if it's the other way around, it would be a minimum. But in this case, it's going to produce a maximum. So quantity is 100. And the price that produces that profit is, well, we've got a price formula. So we'll take our price formula, which is P equals 50E negative 0.01 times the quantity, which is 100. So that's going to be 50E to the negative 1, because when you multiply 0.01 by 100, you get that. So that's 50 divided by E is about 18.394. Now, they want it to the nearest cent, so that's going to be $18.39. So that original profit function is this function here. That's profit based on quantity was 40q e to the negative 0.01q minus 50. So that was our original profit function before we took the derivative. And that's where we find the actual profit. So we've got to plug in P of 100, and that's going to give me 40 times 100 times E to the negative 0.01 times 100, and then subtract 50. So that's going to be 4,000 E to the negative 1, subtract 50. So that's going to be 4,000 divided by E, subtract 50. Again, I don't have, my on-screen calculator doesn't have E, so 4,000 divided by E, subtract 50 is about $1,421.518. So to the nearest cent, 14.21.52.